Okay, for chapter 4.2, it's about the graphing of functions. And for question 1 and 2, you can solve them by using the examples. Just follow the examples on the slides. And if you have questions, just email me. And for question 3, so it gives a graph like this. And now first part A is, does this function satisfy the hypothesis of the mean value theorem on the interval a to b? And part B is, does it satisfy the conclusion? So first we need to know what is a mean value theorem. So mean value theorem, it has two hypotheses. So first is if f is continuous on the closed interval. And second condition is if f is differentiable on the open interval. Then, so this is the conclusion part. Conclusion is there exists at least one number c in the open interval ab such that fb minus fa over b minus a. So that is the first derivative of f. So we can find the kind of slope of this function. So first let's see if the function, so the given graph, satisfies the mean value theorem hypothesis. So hypothesis 1 is f is continuous on the closed interval ab. If it's continuous, yes, because from the graph the line is continuous from a to b. So it satisfies first condition. And the second condition is if f is differentiable on the open interval a to b. And the answer is no. Why? Actually, it explains what does it mean by f is differentiable in chapter 3. So a function is differentiable at a point c if the limit of the derivative for the function at c exists. So which means when x approaches to c from the negative part equals to the limit when x approaches to c from the positive part. So for this graph, actually x is not differentiable as a peak point, x equal to n. So we can solve the limit. So when x approaches n from the negative part, so from the left part, we know it should be the fn minus fa. So that's the starting point a to from n point minus starting point, then over n minus a. And fn is this point, it's a positive number. Then minus fa, fa is 0, then over n minus a. And n is greater than a. Fn is also greater than 0. So when x approaches to n from the left side, the limit is a positive number. But when x approaches to n from the right side, we know you should use the rightmost point fb minus fn over b minus n. And fb from the graph is 0 minus fn. And we know fn is a positive number, so negative fn is a negative number. And use b minus n. b is greater than n because b is to the right side of n. So here, when x approaches to n from the right side, we got the limit is a negative number. which means there has a contradiction, because when x approaches n, from the left side we got a positive number, but when x approaches to n from the right side, we got a negative number. So there is no number can be both positive and negative. So the limit does not exist. If the limit does not exist, then it's not differentiable. So the second condition was not satisfied. So the answer is no. And B, does it satisfy the conclusion? So what is a conclusion? Conclusion is there should be a point on the interval a to b such that fb minus fa over b minus a can be f prime c. So what is fb in this graph? So fb we can see is 0, and fa is also 0. So fb minus fa just 0 minus 0, and b minus a is the length, so it's a positive number, so which is 0, and there should be existing a point c such that f prime c equal to 0. So from Pierce chapter 3, we know the first derivative of a function at a number c equal to 0, that's the slope of the graph. So from the graph we can see there is no, for this part, first part, increasing part from a to n, the slope is not 0 at all. And for the second part, the slope is negative. So from n to b, from a to n, slope is positive. From n to b is negative, and there is no point on the graph satisfy the condition. So there is no, so the function does not satisfy the conclusion, because it does not satisfy either the hypothesis or the conclusion. So there is no point, there is no such a point satisfy f prime c equal to 0, fb minus fa over b minus a. And for question 6, so suppose the first derivative of fx is from greater than equal to 1 less than equal to 3 for all the values of x, and use the mean value theorem to find the values for the inequality below. So this is a given condition in the question, f8 minus f negative 2 greater than equal to something, less than equal to something. So we just use the mean value theorem here. The conclusion part is fb minus a over b minus a. So we can treat 8 as a b and a as a negative 2. What's missing here is b minus a. So we just use b minus a, which is 8 over negative 2. So that's f prime, and greater than equal to 1 and less than equal to 3. So after plugging the fb minus fa over b minus a, so this is f prime or x at point c, and satisfies greater than equal to 1, less than equal to 3. Then solve this equation, because b is 8, a is negative 2. So what we need is fb minus fa. So you just 8 minus negative 2, that's 8 plus 2. So remove a plus 2 to the left side, that's 1 times a plus 2. And remove to right side, that's 3 times a plus 2. So we can put these two answers